the basic properties related to dot products. So now we'll be discussing the same, some basic concepts related to dot products related to the unit vectors. So we know that the whole concept of vectors when applied to 3 dimension, that becomes very important. Okay, x, y and z, any point specified in the 3-dimensional space, it involves the x, y and z parameters. Okay, and here the unit vectors along these x, y and z axis also become very important. Okay, I cap, j cap, k cap. I've discussed about these unit vectors in detail. You can watch the video in the basic physics playlist. So here we'll be discussing about the dot product associated with unit vectors. So this will play an important role in determining the dot product of 2 given vectors. So let us say I cap, the unit vector along x axis. So the dot product of I cap with itself, it can be written as magnitude cos 0 degree, because they are in the same direction. So it will be 1 multiplied with 1 multiplied with 1, which will be equal to 1, because unit vectors are of unit magnitude, whether it is I cap or j cap or k cap, they are all of unit magnitude. So unit vector I cap dot product with itself gives us value 1. Same is the case for j cap and k cap, because they are of all unit magnitude and they have 0 degree angle between them. So we'll get the same result. So I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap, which is equal to 1. Okay. Now suppose we do I cap dot product with j cap. Okay, I cap, which is the unit vector for x axis, and j cap, which is the unit vector for y axis. Okay, let's do the dot product of these. So it will be I cap magnitude, j cap magnitude, cos the angle between them is 90 degree, because x and y axis are at right angles with respect to each other. So obviously their unit vectors will also be at right angles with respect to each other. So because of this cos 90 degree, this result will be 1 multiplied with 1, because unit vectors are of unit magnitude, multiplied with 0, which is equal to 0. So whether you do I cap dot j cap or j cap dot I cap, it is the same. Similarly, j cap dot k cap, the unit vector of y axis and the unit vector of z axis, it is the same. They are of unit magnitude and at right angles with respect to each other, so it will be 0. So whether you do j cap dot k cap or k cap dot j cap, it means the same thing, because vector the dot product, it obeys commutative law. Okay, so ij, jk, or you do k cap dot I cap, which is equal to I cap dot k cap, that is also same, 1 multiplied with 1 cos 90 degree, because I cap and k cap, that is unit vector along x axis and unit vector along z axis, they are also mutually perpendicular. So here what we understand is that the dot product of any of the unit vectors with the other unit vector, it always gives us the result equal to 0. Ij, jk, ki, or ji, kj, ik, in whichever order you want to do it, that will always give us the result as 0, because they are mutually perpendicular, and because of this cos theta thing, cos 90 degree thing, because theta is here 90 degree, this the result will always be 0. Okay, so let's say we have two vectors. Okay, we have a vector A vector which is specified as ax I cap, ay j cap plus az k cap, and we have another vector B vector which is bx I cap, by j cap. Okay, this is j, okay, here, so that you don't confuse between I and j. Okay, j cap plus bz k cap. So the dot product of these two vectors is simply ax I cap plus ay j cap, az k cap, then bx I cap, by j cap, bz k cap. Okay, so here it will simply be ax bx plus ay by plus az bz. That. Why? Because I into I, only ax and bx, they have I cap in common. Ay and by, they have j cap in common. Az and bz, they have k cap in common. And only I into I, j into j, k into k will give us result as 1. All others will give us 0 result. So this will be ax bx, ay by, az bz. With the common unit vectors that will get multiplied, where ax, ay, az are the, the points of the vectors a cap along the x, y and z axis respectively, the values, and b, bx, by, bz are the values of the b vector along x, y and z components. Okay, so x axis. So ax is the x component of A, ay is the y component of A, az is the z component. Similarly here, bx is the x component of B, by is the y component of B, bz is the z component of B. Now, if we try to express it in the usual way, that is A vector dot B vector, which is A vector modulus B vector modulus cos theta, that way. So in that case it will be here A vector magnitude, A vector modulus, that will be ax square plus ay square plus az square, that is A vector modulus. Then B vector modulus will be bx square plus by square plus bz square root over, and then we have cos theta. So here we get an important formula, we'll be getting an important formula related to cos theta. So cos theta is simply A vector dot B vector divided by the magnitude of A vector multiplied with the magnitude of B vector, which is equal to A vector dot B vector, here it is ax bx, ay by, az bz. Okay, and then we have root over of ax square, ay square plus az square, then bx square, by square, bz square, root over. Okay, that is cos theta. And if we want to take the value of theta, it will be cos inverse of a vector dot b vector applied with a vector modulus b vector modulus. It's the same here, cos inverse of this whole thing. Okay, this whole thing. Okay, so here it is an important concept. Suppose you are given two vectors, okay, and you have to determine the angle between the two vectors. You can do it using this formula. First, you determine the dot product, express it in this way, okay, because instead of doing dot product with all these components, we simply know that I into j, j dot k, k dot I, it will give us 0, okay. So directly we just did we determined the value of the components which have the same unit vectors, because only those same unit vectors dot product will give us unity result, one result. Others will be 0, so there is no need to unnecessarily lengthen the whole expression. Then we have this expression of dot product, which is a vector modulus b vector modulus cos theta. So we combine both of them to get the value of cos theta. Once we have the value of cos theta, which is expressed in terms of both scalar values, we can do cos inverse of the value and we'll get the result. Okay, so here we have the dot product of unit vectors and some important concepts associated with it. Okay, so here again, if you have any confusion, see, this whole thing would have been, the whole expression would have been like this. See, ax I cap multiplied with bx I cap, okay, dot product bx I cap, then it would have been plus ax I cap, okay, dot product with by j cap, and like that. So same, it will then become ay j cap multiplied with by j cap, then ay j cap with bz k cap. So like that the expression would have lengthened. Now here we know I cap dot j cap would always give us 0. Here this will always give us 0. So we only pick those expressions where the result will give us unity result, non-zero result, which is this case here. Here k vector dot k vector will give us 1, and this the values, it will give us the same result. So that's why we deliberately chose those components which have the same unity vectors, common unity vectors. Okay, I cap we have ax bx, j cap we have ay by, k cap we have az bz. Only we picked those components and we got the result. Okay, so again, just to clarify, I did this, okay, so that there is no confusion. So here we discussed dot product associated with unit vectors.